Hello, hope you're having a good day because today we are going to be learning about atomic structure. Okay, basically, we're gonna talk about atoms today, so you guys should be pretty excited because atoms are they're pretty cool. Okay, they're pretty cool. All right. So, what do atoms consist of? Well, if I were to list all the parts of an atom, well, an atom would have a nucleus. Actually, no, let's mind map it from here. So we have so this is let's label our mind map here. Parts of an atom, right? Parts of an atom. So then an atom would have, well, an atom. Let's see, atom right here. It would have, what would it have? Well, an atom has a nucleus, and we'll get into what that is in a second. And this nucleus consists of protons and neutrons. And then we also have an atom also has electron shells. Right? And these electron shells contain electrons. So basically this is all you really need to know, okay? These are all you need to know, okay? We're gonna get into what these are in a second, okay? So, let's start with the easy one, an atom. Well, what's an atom? Well, basically an atom is the smallest particle of an element where you can still have the chemical characteristics of that specific element. So basically it's the smallest part of an element. It's the smallest, yeah, it's basically the smallest particle that has the properties of an element, essentially what it means, right? So I hope, let me write that down. An atom is the smallest particle that can still have the chemical characteristics of an element. So basically that's a definition I would recommend remembering, but of course it's up to you if you want to. Okay, let's just get into the whole atomic structure. There's no need to delay it. So let's label these parts. So the middle part, the center of the atom, right? This part right here. This is known as the nucleus. And this nucleus contains protons and neutrons. Okay, so the things in blue, this stuff in blue, these blue circles here, these represent neutrons. And these pink stuff, this pink thing with a plus sign in it, this represents a proton. Neutrons, that's not good English. Okay, that represents a proton. Alright? And then, as you progress outside of the atom, outside of the nucleus, you will find these little things. Now these are known as electrons. All right, these are known as electrons. And now let's get into the characteristics of these. So the nucleus is the part of the atom that contains protons and neutrons, right? Basically the two, you know, heaviest subatomic particles. The two subatomic particles with most mass, right? So let's get into proton. So proton, it has a relative atomic mass of 1. It has a relative atomic mass of 1. It has a positive charge. This is why I've drawn the plus sign here. It has a positive charge. You can write its charge as +1 if you prefer that. And the location is in the nucleus. Pretty obvious. What about for a neutron? Well, the neutron has a relative atomic mass of 1. Relative mass, sorry, not relative atomic mass. It has a relative mass of 1. It has 0 charge, it's neutral. And its location is also within the nucleus, okay? And let's get into electrons. Electrons have a negligible mass. It's 1/1840. Not really, you don't really need to account for that. And it has a charge of -1. So, if you wonder why an atom is electrically neutral, why it doesn't have a net electric charge, it's because the number of protons is equal to the number of electrons. Let's write that down. Number of protons equals number of electrons. Right? So if they're equal and they have opposite charges, well, they're just going to neutralize each other. They're going to cancel each other out. So if I have 2 protons, I must have 2 electrons. So they're just going to cancel each other out. It's not going to be an electric charge, right? So then the mass of an atom, you get the mass of an atom. Atom will be equal to the number of neutrons plus number protons, okay? Because you see, protons and neutrons have a relative mass. I should have written it down, but anyway, they have a relative mass of 1. This doesn't really have a relative mass. It's too small. It's negligible. So that's why the mass of an atom is the number of neutrons plus the number of protons. If you have ever seen an atom on the periodic table, it's gonna look like this. So you have your chemical symbol, your chemical name, and then 1, 1. It's gonna look something like this. Okay, it's gonna look something like this. This is an atom on the periodic table, hydrogen. All right, the top section is the proton number. The proton number is just how many protons the atom has. So in hydrogen's case, it's just gonna be 1. H is just the chemical name of hydrogen. This is, well, hydrogen. The bottom is its relative atomic mass, which is just this. It's the relative atomic mass of an atom is just that. Number of neutrons plus number of protons. All right? So, I would like to ask you a little question. Say I have an atom which has an atomic mass, which has a which has a proton number of 3, and an atomic mass of 7, a relative atomic mass of 7. So now what I want you to calculate about this lithium atom is how many neutrons does lithium have? I will give you some time to think. Alright, so I assume you've thought about it. Well, how many neutrons does lithium have? Well, if you recall, let me get a highlighter here. If you recall, this top number is the proton number. This is the number of protons. Right? And we have the mass number, which is below here. The mass number is 7. 7. This is the relative atomic mass. Well, you might say to me, well, why does this matter? Well, it matters because we have previously determined that the mass of an atom, which is just this relative atomic mass, is equivalent to the number of neutrons plus the number of protons. If we can write it down kind of algebraically so it's easier. So m will just be the relative atomic mass is equal to n neutrons plus protons, right? So if we have a relative atomic mass of 7, so m is just going to be 7, is equal to n plus, well, what's the number of protons? The number of protons are just going to be 3. N plus 3, right? So n is equal to 7 minus 3. N is just going to be 4. So therefore you can conclude that lithium has 4 neutrons. Alright? Okay, I think we have done quite a bit today. I will be talking about isotopes and electron shells in the next chemistry video. I hope you have found this video educational. I hope you found this useful, most importantly. So I hope to see you in the next episode of chemistry, physics, or math, whichever one. Alright, have a good day.